My name is Aaron Smith, and on behalf of EEBA and Team Zero, I'm really happy to welcome our collaboration partner, which is Better Built Northwest, and we're really proud to be collaborating with them. And I'm proud to introduce Dan Wildenhaus. Dan's a technical advisor and industry liaison for Better Built Northwest. And you've probably heard all of us say, build tight, ventilate right. And Dan's really going to dive into detail on this today. As always, you've got the Q&A section at the bottom of the screen. Enter your questions there. We'll be able to answer those. I think we've got 3 waypoints throughout the session today. We'll answer those. We do have a PDF copy that will be posted up on the website. And we are going to put this out in a podcast series as well. Dan and I both said there's no 2 guys that look more like Joe Rogan. So we're really inspired to do a podcast. So those of you listening on the podcast, we're glad to have you. So Dan, I'll turn it over to you.
Thank you so much, Aaron and Nancy. It's just a pleasure to be working with you guys again, and I'm excited for this. I'm going to turn my video off in just a minute, folks, just so we don't have any bandwidth issues, but it's really important for this initial slide here because the image on your screen, the static image, is my pre-pandemic look. And as you can tell now, it's been a rough past 15 months. I kid, people ask me that all the time. How old is that picture? And it's not that old. So real quickly, all right, who is this guy and why is he here? So my name is Dan Wildenhaus, and I've been in the industry a little over 25 years at this stage of the game. I worked for a contractor. I was a Hrvs rater. I kind of took the NASCAR approach. I literally had a patch from every single program on me at one time or another. So over the past 25 years, I've really actually encountered a lot of different things that we're going to talk about and see today. I've seen most of this in the field at least once. For the last 10 or 11 years, I've really worked on helping to implement programs. And one of them is this program called Better Built Northwest. And Better Built Northwest is really a suite of resources more than a program. We don't give a certification or anything like that. Instead, our goal is to roll up as many great industry resources as possible and put them in a couple locations. One location is my brain, right? I am Better Built Northwest. I am our industry liaison. I'm the one who goes out, speaks to people, meets with builders, meets with trades, meets with Hrvs raters, meets with programs. But we also have a terrific website. And we also, every other year on average, not with the virus, but usually every other year, we also have a conference, the Home Efficiency Forum. So we actually put a lot together here. This is just some of the resources that are available on our website. And before we go any further, this is a joke. I joined the Far Side Facebook group, which is really makes my day almost every single day. And it's, the thing here, it's time we face reality, my friends. We're not exactly rocket scientists. And it sometimes feels that way when we're faced with how do we actually get buildings tight and ventilate them right? Now, I'm not claiming that I am the rocket scientist here. Again, I've just seen enough that I'm going to talk about a lot of potential solutions here, knowing that there's always another way to do it, and not everything I'm going to bring up is going to make sense or work for you. So with that said, what do we mean when we say a tight home? Well, we're not colonizing Mars just yet, so I don't mean a hermetically sealed bubble. For the sake of today's argument, we're going to say 3 ACH 50 or less. Let's call that a pretty tight home. And you can make an argument, you're not tight till you're under 1. Whereas people who come from a state that hasn't had an energy code promoting this yet, they would tell you that 4 or 5 is pretty tight. But let's use, for today's math and today's thinking, let's use 3 air changes per hour to more or less describe a tight home. So when it comes to ventilation, people rightfully bring up some things like, well, if the power goes out and this home's really tight, there's this concept called passive survivability. How am I going to be able to survive in the house? Wouldn't it just make more sense to let my house leak all the time? Well, this is a great graphic from Paul Francisco. This was originally when ASHRAE 62.2 was first hitting the weatherization and home performance market. He came up with this to help explain to people why we need ventilation. So I'm going to start with this, and I'll answer the passive survivability. On this graph, you've got 3 lines that kind of curve from the left and dive down to the right. The blue line is a really, really leaky house. The red line would be a house meets energy code of maybe 2006. And then this green line, that's a house that's about 4 air changes per hour. What it's showing you is that even that really, really leaky house still needs some ventilation when it's over 60 degrees outside. So the horizontal line that's red and yellow together, that's the minimum ASHRAE ventilation rate necessary for that house for good indoor air quality. Even a leaky house, when it's the right warmth outside, there's just not enough driver. There's not enough stack effect, reduced wind effect, and there's fewer mechanical effects because the heating and cooling systems aren't running as often. So every home needs some ventilation. The tighter you get, the more you need mechanical ventilation. So the little green line needs it all the year round. So what do we do about passive survivability? It's a real legitimate thing. Look at Texas. You lose power for a week. What's going to happen to that house? Particularly if people don't read the instructions and actually bring a barbecue in the house, right? Please don't do that. So some passive survivability techniques are, whenever possible, incorporate into design the ability for high-low natural ventilation, meaning the ability to open windows high and low in the house, and to provide cross ventilation streams throughout the house through opening windows. And I would suggest that we're at a point now that every high performance home should have a homeowner's operation manual. I mean, isn't it ridiculous that I can go out and buy a Blu-ray player still, and it comes with a 95-page manual in 3 different languages, and it cost me $59. But I can spend $400,000 on the house of my dreams, and it often doesn't come with the homeowner operation manual. So get the education right, put in a homeowner operation manual, and build in some passive survivability. But what about just using exhaust ventilation, Dan? It's cheap, it's inexpensive to operate, so it's cheap to install and a low operating cost. I mean, isn't that just a really good, solid way to do this? Maybe we'll worry about balanced ventilation later. Well, the problem with sucking air out of the house is that new air has to come in from somewhere if you don't bring it in intentionally. And I just ask you, are these the kinds of places you want your fresh air to come in from, right? Do you want it in a crawl space or attic that's rodent infested, or maybe it's got moisture issues? Or do you want to pull air from the garage where you keep your lawnmower and your gas can and your extra cans of paint? Washington State University Energy Program had done a study a number of years ago and found that even in code-built homes that were 5 or 4 air changes per hour, approximately 40% of the quote unquote fresh air in the house was coming directly from the crawl space due to a combination of exhaust only ventilation and stack effect. So maybe that's not an ideal scenario for a way to ventilate our house. Okay, well, we've moved on from that, Dan. We actually have a duct that comes into the return side of our central air handler for our either furnace or heat pump. And that pulls air in from outside and distributes it around the house. Well, that's lovely. You're now creating a positive pressure in the house. And that doesn't sound like it's as bad. At least I know where my fresh air is coming from, right? Supply side ventilation, maybe this isn't such a big deal. Well, one thing, which I'm not going to go into too much detail here, is that you are using the biggest fan in the house, that central air handler, to do your ventilation rate. That's probably not the best use of fan energy. But more importantly than that, when you positively pressurize a house, what happens to the air from indoors if it gets into an exterior wall cavity or an attic, right? So that warm, moist air actually has some pressure behind it now because you positively pressurizing the building. It enters this insulated cavity. As it goes on, it will eventually achieve the dew point, the point at which you're nearing condensation, and then it could hit a condensing surface of interest. And when that happens, you can get mold, you can get mildew, and maybe worst of all, you can get lawyers. And as far as I know, unless you are a lawyer yourself, most people do not want to invite lawyers into their home, particularly for anything other than dinner. So positive pressure, while there is some value to this concept of at least I know where my air is coming from, it's not necessarily a great thing for your building's durability or potentially for the fan energy use. But Dan, how do I actually sell balanced ventilation? I mean, this just sounds like you're increasing my costs with something behind the walls that no one will ever connect with. Really? These are from my good friend, Bruce Manclark, who actually collects ancient advertisements for things about our homes. And here we've got one for weatherization and one for ventilation. They were figuring out how to market this in the 30s. If they can figure out in the 30s Now, this is before COVID times too. Just think in the last 15 months, how we change what we do in our homes. My apartment is now my workspace, my gymnasium, it's my rec center, it's my movie theater. I mean, it's everything. So what approaches can we actually do here? There's a couple different ways to think about it. In some states and some programs, there's a mandatory requirement. So one example there is the 2021 Oregon Residential Specialty Code. That's our energy code in the state of Oregon, and mechanical code. And it states that you must have balanced ventilation, mandatory, and they describe that as plus or minus 10% of the airflow or 5 CFM, whichever is greater. Others choose to do something similar, but instead they penalize you if you don't meet it. And the Washington State Mechanical Code is a good example of this. If you're not both balanced and distributed, you have to put in a larger fan or move more air. So they actually have a little table set up here that shows you, if you're both balanced and distributed, you multiply your necessary fan flow rate by 1. But if you're neither balanced nor distributed, or if you're not one or the other, it's a 25% or 50% penalty. So now we're actually talking about forcing people to buy larger fans and to move more air. So again, we're just looking at this straight up to say, whether it's an or else scenario or a mandatory scenario, these both tend to get towards the same point. You want to be able to move the same amount of air in as you're taking out, assume within about 10% or 5 CFM, whichever is higher. Whew, take a deep breath. I will admit, sometimes sitting through a Dan Wildenhaus presentation is a little bit like drinking from the fire hose. So we're going to, as Aaron said, take a couple of breaks to pause just to check to see if there's any immediate questions that we can address before we get to the next section. So Aaron, anything pop up that we can address now? Otherwise, I'll just take a deep breath and a drink of water.
Dan, I think you have a lot of the tinier homes that are popular in the Pacific Northwest. What about the ACH 50 penalty for tinier homes? How do you deal with that?
It's a great question. So there's a concept that we use ACH 50, unfortunately, in my opinion, for a lot of our calculations, meaning we base how much ventilation and how we measure it based on the volume of homes. And the reality of that is that tends to make it harder for really little homes and easier for really big homes.
Right.
And volume isn't really the best thing. Me personally, I would base it per bedroom. You have 3 bedrooms. I don't care if you're 3,500 square feet or 6,000 square feet. You have the same building tightness requirement. A different strategy is to look at CFM of surface area. Now, Washington State University did or the Washington State Energy Code did a really interesting way to do this instead. They said for the calculation of building tightness only, if they give a target of say 4 or 5 air changes per hour at 50, you do the conditioned floor area and you multiply it by 8.5, regardless of how tall your walls are. So regardless of some are 8 feet, some are 9, some are vaulted ceilings, multiply everything by 8.5 and use that volume number only. And it was one way to try to help neutralize that a little bit.
Yeah.
Again, not perfect, but better than nothing.
Great. And what else? What are you seeing? Are you seeing across the country more requirements for balanced ventilation? I know I'm here in Minnesota. We have a requirement in the code for balanced, but what does the landscape look like right now across the US?
Yeah, this is where you typically see this as either an amendment to the IECC or IMC. I just checked yesterday, and the 2021 IMC and IECC do not yet mandate balanced ventilation, but a lot of states will add an amendment to that if they're an IECC state. Otherwise, we're starting to see this really come about in programs, above code programs. So the Dozer program is a really terrific example, or Passive House, or any number of regional programs. And those tend to be the really big drivers. We are also seeing some savvy HVAC contractors recognizing this as a business opportunity. You'll notice I titled this Chasing Opportunities at the beginning. To be able to, quote unquote, provide a solution to a builder that the builder can turn around and sell. And we're going to come back to some of the sales ideas near the end of this presentation. So it's either usually driven by programs, states that are adopting amendments to the IECC, or really savvy HVAC contractors.
Great. That's the questions for now. We can drive on.
Awesome. So if we're going to do this, we have to build tight and ventilate right. So let's talk a little bit more about building tight. I don't want to dwell on this. This is a poster we created, thermal enclosure best practices poster, available on Better Built Northwest. There's a nice little legend that you don't see in this image that kind of outlines all of these points. And it's kind of a visual version of a checklist, if you will, right? A great way to have that initial conversation if you're a builder with your trade, if you're a rater with your builder, et cetera. Great way to get yourself started. So let's start by, again, remember I said, to me, tight was 3 air changes or less. So how do we get to 3 air changes from wherever you are today? Well, the first thing is paying attention to your top plates. This is a product using top plate air sealing gaskets. And I'm going to quote from a couple of studies we did in Oregon with the Energy Trust of Oregon. And this one was just a study 7 years ago to say, what kind of benefit do you get on a house if you just air sealed the top plates? So they picked 40 homes. There was 40 homes that were treated, 39 in a control group. They used 2 insulators. One of them did 80% of the jobs. They were standard bats for starters. These were all homes over vented crawl spaces with standard building wrap. So there wasn't anything overly fancy, and they weren't on slabs or basements. So I just want to set that precedent for you of what we found. Another study we did at the same time was a Bibs versus bat study. Again, this was 40 treated homes, 40 untreated homes. In this case, we had 1 builder using the same subcontractor the entire way through. All homes were tested in late summer or early fall, so we didn't have to worry about them being open for long periods of time or getting wet due to rain. And these were all, again, also 2-story homes built over ventilated crawl spaces. So what were the results? Well, just doing top plate air sealing got us about a 0.8 reduction in air leakage in that group when we compared one to the other. So just focusing on top plates got us a 0.8 reduction. Now, keep in mind, again, these were separate years. It just was coincident that the starting numbers were similar. Looking at blown in versus bat, we got a full air change reduction. On top of the fact that those ones already had top plate gaskets. So one of the main things we can talk about right off the bat is making the move as soon as possible to blown in bat insulation. Not only do you get better R value in your walls, boom, you're instant, and you get grade 1 insulation almost every time. You are also getting, typically for your 2,250 square foot house, about an air change of reduction. And then focusing on top plates will get you close to another air change right off the bat. Beyond that, it's really just attention to detail. And there are some really great checklists out there. In the Northwest, we have this one called the Air Barrier and Air Sealing Checklist from the EPS New Construction Program. It's, if I'm being honest, it's a whole lot like the air sealing portion of the National Rater Field Checklist. Both are really great. You could use that visual checklist I showed you earlier. There's also some guidance in ResNet as well as in the IECC for locations to focus on. What if I wanted to get down to 2 air changes per hour, right? What if I want to go that next step down? I'm really shooting to get tight. Typically, homes that are shooting for 2 ACH 50, the thing we see most common is moving the air barrier away from the inside drywall and putting it on the exterior wall. When you do that, the real critical components are, how do you connect that exterior wall to the ceiling and to the floor? Because those are going to be your 2 biggest weak spots. This, again, is another poster that's posted on our website, and we've got it for single walls and double walls. I encourage you to go to Better Built Northwest and check out the thermal enclosure efficient walls and air tightness poster. When we do this, one method is to use roll on, paint on, spray on, unified weather barrier / weather resistive barrier / air barrier all in one product. That's a great thing because, believe it or not, there is a little bit of air migration through OSB and plywood. Not a ton, but a little bit. So this is one way to do it. Another is to use your sheet product and do a really great job of taping the seams. Another technique that people are using is to say, I'm going to actually treat my insulation, my continuous insulation, as my exterior air barrier here. And so really doing a bang up job again of taping the seams is a really terrific way to get your initial tightness. But now remember, I said the really hard part is that intersection. So let's take a look at the intersection to a ceiling plane, because this is where things get interesting. And this is from my buddy, Josh Salinger from Bird's Mouth Construction. He does absolutely great work, and he just presented on this a week ago at a conference I attended. So I conveniently stole some of his slides. But here he's prepping this wall to be able to tie in an exterior air barrier with a ceiling barrier. So you'll notice that there's some steps that they do here. First, they've got this kind of adhesive wrap product that's going to be able to integrate with the exterior wall to your ceiling detail. That's this blue Siga product. And he puts that on top of the wall frame, and it comes down several inches on both the inside and the exterior before the trusses are installed. Then he puts on the trusses, and then he puts a membrane on it. In this case, he used a Siga Smart membrane, which it's just a type of membrane that, depending on things like pressure, temperature difference, and relative humidity, allows varying degrees of moisture to move through it. It's a really terrific product. This is his first one, and this is with you can see a cathedral ceiling here. So he's got his Siga membrane, and then he actually notice he's got 2x4s on their side running the length of his ceiling. This effectively is going to create a channel up there so they could run low voltage wiring in that channel. If they had a surface mounted lamp, something like that, it could be mounted without sticking up and getting in the way of the air barrier. And then they put up the interior walls on the top floor. And this allows them to get a really nice barrier. That's one way he does it. Sometimes he also does it with a rigid product. So here he put, coming in about the first 18 inches around the perimeter, he's got plywood, and you'll notice he did a really good job of taping up the seams on the corners. So now we've transitioned. Now they can put their truss package on, and then they go inside and literally put up sheet product. It could be anything. It could be drywall as a first layer and do 2 layers of drywall. In this case, they're using OSB and doing a really great job of taping those seams. So these are 2 of our great ways to get to 1 ACH and 2 ACH, or 3 and 2. But what if you want to go down to 1? Well, there's a product out on the market now called Aero Barrier. You may have heard of it. You may have even used it. We're actually starting to see the price of this come down because our energy codes are pushing people to go down to 1.5 air changes per hour or 2 in Northwest states, the way our codes are written. So people are really looking for fast ways to get there. And we're seeing the price per square foot come down, in some cases below $1 a square foot. And that's usually in some of the markets where there's more than one representative from Aero Barrier that kind of is capable of working in that market. So the way this works is, first, depending on the size of the house, they set up several of these little dispersal sprayers. Then they positively pressurize the building, and they fog the air with this mist, which is basically like latex caulk that's been microized. And they run it with a computer here. He's actually outside of he's not breathing that in, pressurizing the house, and all that stuff will float and find holes. And as it gets to a hole, it increases velocity. And what happens with that latexy stuff is, once it starts increasing velocity, it starts getting sticky, and it starts sticking to itself. And so he can actually monitor this on his computer and generate a report that shows you how tight they've gotten over the course of a couple of hours, a half a day. Really depends on how tight your house was to start. And what it ends up looking like when you're done, you can see it's actually looks like someone kind of put some rough caulk or some duct sealing pookie over these holes. You'll notice this case, they did spray foam first, some of the big holes, but this Aero Barrier product collects, again, it gets sticky and it only sticks to itself. And when you're done, you just sweep up the floor and wipe down around your windows, and you've got a pretty darn good air barrier. So that is the product that we really see for builders trying to get under 1 air change per hour. Now, again, there are other products in the market. This is not the only way to get there, but those are 3 critical ways. The checklist detail way, moving to an external air barrier and paying close attention to how you transition from walls to ceilings or floors, and then using products like Aero Barrier in the marketplace. So this seems like a pretty good place for me to take a breath, get a drink of water, and check for any questions.
Yeah, we've got a couple questions coming in, and one is, and you may want to answer this later on, but I'm going to ask it right now because someone put it in. But this person has a heat recovery ventilator and
Okay.
a house that is at 3 ACH 50. And they're wondering, how do I deal with the range hood and dryer? Do I need a passive fresh air vent? Assume the range hood is less than 400 CFM.
Yep. It's really a great point. The tighter that in, so we didn't address this too much earlier in here, but it is true. The tighter your home gets, the harder it is for exhaust equipment to do its job adequately.
Right.
Some codes, like the mechanical code, depending on how states adopt it, actually mandate if you have anything over 400 CFM that you need to build makeup air into the equation. If you take a look at the opposite of passive house, they flip the script and they will put an exhaust port from the HRV in the kitchen and then put a recirculating fan hood in that space. So that does the job of trying to be a grease catcher, but then the whole house is ventilated using the heat recovery ventilator. If you do an approach where you are doing recirculating fans for kitchens, for instance, and you're just going to use your HRV to do the whole house ventilation and the spot ventilation, we recommend that you upsize your HRV so you can run it at low speed continuously, and you can hit the boost button, or the party mode, as I like to call it, to hyperventilate for shorter periods of time after, say, a cooking event. Dryers are a really, really another big question to this, and dryers move a lot of air.
Right.
One approach is we're seeing a migration to heat pump dryers or condensing dryers,
Sure.
which do not have an exhaust, but that's obviously not everybody's there yet. So if you're getting much below, if you're getting to 2 air changes or below, you really do want to think that through, and you may want to have a makeup air vent into your laundry room with a damper that is controlled either when the dryer comes on or it's controlled with static pressure. I have seen dryers and kitchen range hoods depressurize homes to 15 pascals negative pressure when they're cranked on in really tight homes. I've seen that in real life, and I've actually seen that hyperventilate in HRV because the negative pressure was so strong, it unbalanced the heat recovery ventilator. So it does make sense to really think those things through.
Great. No, great answer. Thank you. Second question is, appreciate your comments on challenges in the Mid-Atlantic region. 25 years experience retrofitting a 1960s house with balanced ventilation has created serious challenges, problems with trying to integrate balanced ventilation in a humid, wet locale. Very few HVAC companies know how to do it correctly. ERVs remove energy recovery ventilator for the audience, remove negligible water vapor, and integrated full airstream dehumidifier is necessary, or indoor humidity soars above 50% when you ventilate during wet, humid, hot months. It's virtually impossible to get balanced ventilation airflow with modern variable speed HVAC air handlers and 3 different pieces of equipment with their own non-sync fan. And finally, ERV paper cores will become moldy in humid climates.
Yes to all of the above. That is a true challenge. You know, when you are in the Mid-Atlantic or Southeast portions of the United States, the wrong decision is to think that an ERV and or a heat pump / air conditioner are going to take care of all of your moisture loads, particularly when you get to a tighter home, because now you're not just contending with outside air that has high relative humidity. You also are likely having higher relative humidity inside your air, inside your space. So an inline dehumidifier ventilation system is probably the strategy you have to go. In those scenarios, I'm going to say add a dehumidifier to options 1 through 4, potentially on this list of other balanced ventilation strategies. So you don't have to spend your money on energy recovery ventilation. Might be a smarter, more responsible use of your time and effort, and in the long run, the energy use of the consumer.
Right. And just to plug, but Terry, I would encourage you to go back to the EEBA Academy and watch. We have a presentation from April Air on their dehumidification strategy for climate zone 3 and below, and also one from Santa Fe Ultra Air dehumidifiers on their strategies. And I think that's great advice that Dan gave.
Perfect. Yeah, and there's some really great people, online.
Yeah.
Nikki and some others that I track that just do a great job. Yeah. They're constantly having these conversations and they're constantly elevating this to a higher level. And I noticed my buddy Dean from EPA is on the call, and there's going to have to be some things where programs take a look at this and say, climate by climate, we may need to or want to adjust specs or make allowances for additional pieces of equipment to address these things.
Amen.
So great question.
Great. Yeah. Thanks.
Yeah. So balanced ventilation doesn't have to just be a heat recovery ventilator, right? That's kind of what pops into our brain when we hear balanced ventilation. But there's actually, these are just 7 strategies that we're doing a field study in Oregon with builders to see which of these are most likely for them to do and what are the lessons learned when they do it. So I'm just going to go through some of these kind of quick, and then we'll spend a little more time on the ones that I think have the highest value. So the first is, we have a lot of builders in the western half of the United States who do what we call a supply side ventilation strategy, or more colloquially, a hole in the return system, right? Literally, it's a duct coming into the return that goes to outside. It has a mechanical damper, sometimes a volumetric damper as well. And that's controlled with a fan controller that will also turn the central air handler on to suck air in from outside and push it around the house. It's actually a pretty common strategy. But as we move to balanced ventilation, potentially the easiest option is to just make sure you upgrade 1 or 2 of your exhaust fans in the house. Could be a kitchen range hood, could be a bathroom fan, and you interlock them so that everything runs simultaneously. And the best bet is to run things on low speed continuously, as opposed to running them intermittently. But if you do them intermittently, there's an answer and a solution there as well. You can use a product called a fan cycler. And the fan cycler will actually take advantage of run times for heating and cooling, and really maximize your ventilation rate during those times, and then settle back down to low speed or even turn itself off for periods of time when you're not calling for heating and cooling. In shoulder months, that's not going to stop the thing from running. But what this does is this reduces the amount of time you get cold air blowing on grandma's head in the middle of January, or bringing hot, moist air in from outside during the middle of July or August. So this strategy can work. You see that there's some incremental costs. The first one was what is the baseline for a lot of Western states, is that supply side ventilation and then just interlocking with an exhaust fan. There's a slight incremental cost to do this intermittent design, and that's really the cost of the fan cycler and a little bit of extra wiring, but it actually provides a little bit of savings because you don't have to run that air handler quite as often. Some of the benefits, again, for many builders, this is not a huge step for them. And if you're the kind of builder who you're like, I hate continuously running things, and I think my homeowners do too, I love intermittent runs. Well, I don't personally, but if that describes you, this is the choice for you, maybe. They can be hard to commission, though. That fresh air can come in off the roof, really high on an exterior wall, could come through on lapped siding, and each of those present their own unique challenges of how am I actually going to commission this? And you want to be careful. Some jurisdictions mandate full commissioning and reporting on that. There's the 2-fan balance strategy. I first saw this popping up in Arizona, New Mexico, Texas, Oklahoma as a strategy. So you buy basically an inline supply fan, and you can purchase one that is the same, rated airflow as your exhaust fan, or several manufacturers, Broan, Panasonic, Delta Breeze, sell products with that you can dial in the flow. And so you just literally match the exhaust flow with the supply flow. One of the benefits here is some of these brands sell a lot of add-on features. So they could sell a filter rack. They might sell a UV light. They might sell an inline duct heater, or you might be able to attach a dehumidifier to this strategy. It's not a bad strategy, but you do have to be a little bit concerned. You're not tempering that outdoor air at all. So you have to be really careful when you supply it to the house where it goes. If you are incorrect, grandma will get 30-degree air on her head in the middle of January. That usually does not equate to happy homeowners. So there are some benefits to this. Relatively easy to commission, and the supply fans have all these great add-ons, which is great. And we've already seen, like I said, a trend for this in a lot of states that are not, from the national perspective, trying to address balanced ventilation from a cost-effective standpoint. The challenge is, of course, there's no conditioning of the air coming in. And you probably want to make sure you're getting really high quality fans rated to run continuously for at least 10,000 hours. And that just instantly cut out 3/4 of the exhaust and inline fans on the marketplace.
Yeah.
Right?
And Dan, perhaps quieter fans as well, right?
Absolutely. So one of the benefits of going with an Energy Star rated fan is it's rated both for energy use and SON rating, which is the noise rating. And there's usually a quality component to it, to an additional kind of quality component for Energy Star rating. So yes, you definitely want to be really intelligent about your fan selection with that strategy. A strategy we see a fair amount in the retrofit world, or have seen in the retrofit world, up and down Western United States at least, is, maybe it's really difficult to get to that central ductwork here. So we actually do a strategy where it's very similar to what I just described, but you put a larger fan in and you pull some air from inside the house and the air from outside the house and let that mix before you push it around the house. It's kind of a tempered air solution. It does have just change your incremental cost, right? And obviously this has its own set of challenges potentially. Some of them here, the benefit is, again, it's a lot of the same benefits as before. It can be nice and quiet. It does temper that incoming air, but you're going to need a larger supply fan. So if you had a rate of 75 CFM you needed to provide, you now need a 150 CFM fan if you're going to mix the air 50-50, with inside air and outside air. It can be confusing if you don't line this out great for installers. And during really cold months, you could literally and figuratively create the perfect storm in that ductwork. When I say literally, I mean, warm, moist air from the house mixing with cold, dry outdoor air in ductwork, you may have some condensation issues. And these, so you would have to maybe want to consider, do I need to design this with a condensate drain? These are all the real. Another option is looking at spot energy recovery ventilators. These little Panasonics, or, the Lunos system would be kind of similar to this in concept at least. And there's a lot to like about it. The cost being one of them and the ease of installation. But there are some real potential challenges with this, right? So again, mostly balanced if you do them right, easy to install, but the challenges are the flow rates on these are really, really low when you want to keep it balanced. So with Lunos, it's real low per pair. And so that makes them really expensive. For the Panasonic, you can't run it at 40 CFM and stay within that 10% airflow. You're no longer balanced. You need to go 30. So you may need to install 2 or 3 of these to meet that 60 to 75 CFM net need for the house. If you're only able to move 20 or 25 at a balanced flow, you're going to need 2 or 3 of these. You're also not distributing the air to the bedrooms. So you may need to have use a central air handler, maybe for 10 minutes out of every hour, it comes on to mix the air throughout the house. But depending on the way your state rules are written, if you remember, Washington State actually penalized you for not distributing the air to all the bedrooms. So in that case, you might even need 4 in Washington State because there was a multiplier to your necessary airflow. Standalone HRVs and ERVs are wonderful devices. They really do give you a lot of opportunity. This is where the design makes all the difference in the world, because where am I going to put all these extra ducts, and where am I going to put this equipment, and how am I going to get all of this working so that not only does the install go smoothly, but people can actually get at it and change the filter, right? People can actually check the condensate drain if it's an HRV, or check the paper core if it's an ERV, to make sure over time that these devices are still working well. The incremental cost is going up here as well. I do want to pause for a moment to say, be careful when builders or HVAC companies tell you straight up that these are $4,000 to install every time. We've actually been really doing the research, and I just did some online shopping last week, and looked at these, and I found 3 or 4 models within 7 minutes of online shopping that met Washington and Oregon's minimum requirements for heat recovery ventilation that were all under $800. Yeah, you still need to install it and do all the ducting. So we have a estimated cost of closer to $2,600, but that's still a far cry better than $4,000 or $5,000, which is what we're hearing on some quotes. So it's about product selection. You do want to do it right. We really like the idea that it's balanced, it's distributed. If you have a really good fan, this is where you can really start to save energy in the building. And you have the opportunity to still take the exhaust out of bathrooms. Now, we don't recommend, unless you get a really, really tight house, maybe below 1.5 air changes per hour or under 2, there's not a need at 3 to get rid of all your bathroom fans, your spot bathroom fans. But maybe you can switch down from a 70 or 80 CFM fan to a 40 or 50 CFM fan, because you're just trying to defog the mirrors at that stage to meet your spot ventilation codes, because you're using that central HRV for the continuous ventilation for whole house. And as long as you're pulling from every bathroom, you can count that towards the spot ventilation needs. If it's a laundry room or utility room, you may not need any fan in there at all beyond an exhaust port for the HRV. The challenges, obviously, cost and ducting are 2 big components. And then not every brand makes it as easy to commission and keep these balanced as you'd like. And you do want to put these in a really good location. Ductless heat pump and radiantly heated homes, this is a really good opportunity because you're not fighting for space and walls in between floors with the central HVAC system. So we do love it for those scenarios. One that my buddy Bruce and I did several presentations on a few years ago, and even got written up in Green Building Advisor, was this idea of integrating your heat recovery ventilator into your central air handler. So if you've already got a gas furnace or a central air source heat pump, one option is to say, I'd rather not run my HRV ducts everywhere if I've already got a system running ducts everywhere. So why don't I just connect my HRV to my central air handler? And you can do that. And there, again, the incremental cost is still there. While you're saving a little bit on total amount of ductwork, the complexity of the install is a little bit higher. So we actually juiced the cost up a little bit for this. Again, balanced and distributed ventilation, really great. Uses the duct system that's already there. We love that. The exhaust side, we're still pulling from the bathroom, so that same benefit. The challenge is, of course, cost. And this is where commissioning and balancing now is a whole nother discussion and how you're actually doing this. There's also varying control strategies, and it really matters how you try to set up your control strategies. It's your best bet is to run both continuously on their lowest speed that satisfies the ASHRAE ventilation rate or the IMC ventilation rate needs for the home when it's not calling for heating and cooling. That's going to get you your most consistent, what we call predictable performance, which if you benchmark the way you build as a quality builder, then the words predictable performance should come out of your mouth every time you talk to a Hrvs rater or an HVAC contractor or an insulator about an energy efficient upgrade. Ask about predictable performance and make the selection that aligns with that, because that is how you're going to continue to define quality. So this strategy, you may have noticed, I can go into much more detail. We have a whole nother presentation about it, but you'll notice we've got it injecting into the supply side as opposed to the return side of the central air handler. And one of the reasons why is if you connect to the return side and that central heat pump turns on, it's going to depressurize the return duct, which is going to accelerate the airflow through that half of the HRV. And you can literally unbalance your system and it will throw out a lot of your efficiency out the window. If you connect it to the supply side with an injector port, which is really an elbow turning in the direction with the direction of the airflow, it kind of creates a little eddy in the airstream. And we've actually tested it and been able to show that you can inject exactly the amount of air that you intended to in there. If you want to talk more about that, feel free to connect with me and I'm happy to go down it. Before we go much further and start talking about the sales and some finer details, this is a really good time to pause and see what kind of questions or conversations may be coming in.
Well, Dan, just the age-old question for the audience, which is when to use an HRV and when to use an ERV?
Yeah, it's a great question. When we first started piloting this with, we had a project, gosh, it was the first round was 20 homes, and the next round was 40 homes in the Pacific Northwest. So we were looking at the Marine Climate Zone 4, Climate Zone 5, and Climate Zone 6. And the Climate Zone 6 is like northern Idaho and most of Montana. And that's pretty darn cold. And actually, there's a little niblet of Climate Zone 7 kind of nibbling at the corner of Montana. So we actually looked at this and put ERVs anytime we felt that the exterior winter design temperature dropped below 15 degrees was our own kind of, we had to throw a dart at the wall somewhere, and that's where we threw it. And so whenever we had a winter design temperature that was really, really low, because that was usually associated with really dry outdoor air, or if you're at a higher elevation than 2,500 feet. And we do have a lot of towns built up in the mountains. In both of those cases, we were trying to address the dryness of the outdoor air, trying to make sure that we didn't over dry the house. In that scenario, what we found is that in the tighter the home was, the less it mattered whether you used an HRV or an ERV. There's just enough tightness in most homes that you're going to be fine with an HRV in a cold climate, as long as the building's really tight. So if the building is closer to 3 air changes per hour or higher, an ERV makes all the sense in the world. Now, if you're looking at, say, the Southeast, where you're talking about high or the Mid-Atlantic or lots of places in the southern, in the kind of southern belt of the Midwest, where you have, you know, anywhere from 3 to 9 months out of the year where you've got a lot of relative humidity outside, and you're trying to prevent the outside relative humidity from coming in. This is where you have to start the conversation first with, do we want to bring an intentional dehumidifier into the building first? Start there and then worry about whether or not you use an HRV or an ERV. As it was pointed out earlier, a comment someone made, do not try to rely on just a cold, extra capacity, continuously running heat pump and an ERV to take care of all of your relative humidity issues. It might work if you only need that for a couple of months out of the year, but if you live in a climate zone where you've got a lot of outdoor relative humidity, stop the conversation. Don't start with, do I need an HRV or an ERV? Start the conversation with, what's our best strategy to dehumidify the necessary volume of air we have coming in? Now, at that stage, an ERV may be beneficial to you because it may reduce the impact a little bit on your dehumidifier. And the same with a continuously running heat pump. If you get the variable capacity models and most of your, depends again where you're at. If you get a lot of relative humidity when it's only 60 degrees outside, that's not going to help you, right? But it will help lessen that burden if it's both hot and humid outside. So that's my first thing is, HRVs are great for most of the country. If you're in a high elevation, really cold and dry climate, and you're not too tight, an ERV is a great option. And if you're in the Southeast or the Mid-Atlantic, probably an ERV, but don't start there. Start with the question and discussion about dehumidification.
Well, that's great. We can move on.
Awesome. So in selling HRVs to homeowners, so this is some guidance we've got from actually talking with the builders that are actually doing this and are actually successful with it. Differentiation is ideal number one. So connect the concept of good indoor air quality, or as Ian Walker would say, or Brett Singer, a reduction of the risk of bad indoor air quality. It's maybe more fair to say that. I should probably update my slide deck. Associate that with a tangible product. So one of our builders, they proudly put it in the laundry room. They actually gave up some storage space, put it there because they make it a key feature of their home. And it's something they point out, and they give really good talking points to their sales agents. talk about the fact that, we actually take exhaust from all the rooms where moisture and pollutants are generated. This is a benefit to you. We do it with one system instead of a whole bunch. We actually bring fresh air to all parts of your house, not just dump it into the middle of the house. And shouldn't an energy efficient home have an energy efficient fresh air solution? All of this leads us to happier and healthier homeowners. Think about how this has changed again over the last 15 months. Is this message resonating more? If you're looking for better ways to have your sales staff try to communicate this, because admittedly, this can be kind of challenging. We highly recommend the Building America Solution Center sales tool. It's a great way to put most of our challenging energy efficiency and building science topics into homeowner-friendly language. So check that out. That's a really good way, but start with differentiation and make this a key focus. We have another builder who refers to this as the lungs of their building. It's not the perfect analogy. I know Allison Bales and some others have kind of rallied against that specific analogy, but it's, it gets the message across, right? It's the part that's helping the house breathe. So whatever the message is, as long as it's not an outright lie or, an episode of Fear Factor, it's make this about a tangible product you can connect to a reduction of risk for bad indoor air quality, and that will help you sell. When it comes to finding HRVs, if you're not already familiar with HVI, the Home Ventilation Institute, hvi.org, it's kind of like AHRI is for heating and cooling equipment. HVI is for ventilation products. And you just scroll down to, I think it's grouping 3, which focuses on HRVs and ERVs, and you'll get a product listing like you see here. So you want to look at typically the net supply. That is does that number meet your ASHRAE or your IMC ventilation rate? And then you click on the more details and it will give you different performance ratings at different temperatures. And just check with your local jurisdiction or your local program. Most will say pick the one at 32 degrees, the number there for your SRE, and that's your efficiency. And then I always take it and turn it into a spreadsheet, and I do this power consumed. I take that max watts and I compare that to the CFM. So I can get a watts per CFM or CFM per watt, which is the fan efficacy. So it's another way to do your kind of grading. We are starting to see programs attach that as an additional metric, not just the efficiency of the equipment, but that fan efficacy, because if the thing is running all the time, you want something that moves more air per unit of energy used. That's going to give you your best bang for your buck. Now, there are some darn near mythical creatures out there. I didn't want to spend too much time talking about these today, but if you're at all curious, they're really worth looking into. I've had representatives from both companies as guest presenters for a monthly series that I do for a bunch of home energy raters in the Northwest. And what both Minutair and CERV2 do is they actually have a heat pump inside this HRV box. I'm not kidding. There's literally the compressor is inside the box as well. In fact, the Minutair has an HVI rating over 100% on heat recovery, which sounds impossible, but it's because the waste heat off the compressor, which is in this box, gets reintroduced into the airstream that it needs to, and it really boosts up the overall SRE, or sensible recovery efficiency of the equipment. So the size of the heat pump that's in there is not huge, but if you're doing smaller houses or passive house, or maybe an addition, or you converted the garage into your teenager's cave, these types of products are kind of pricey, but they really can do several things at once. And both companies are really focused on indoor air quality as their main mantra. So really cool stuff. I highly recommend looking into both of them. And Ty over at CERV and Alexander over at Minutair are both awesome guys, and they will gladly talk to you as long as you want to about these products. Really cool products out in the marketplace. As we're getting near the end, I've got several pages worth of resources here. I kind of tried to boil it down to 2, because I know we just talked about an awful lot of stuff, but almost everything that was mentioned today has some connection to one of these links. So you've got more than enough to back you up when you move along. So on this page, the HVI product directory, I mentioned Energy Star, of course. This you see to the right here is called the HRV system best practices poster. My buddy Bruce and I developed this, and it's kind of a decision tree for thinking your way through the selection and design criteria for heat recovery ventilators. We also have several presentations available. Again, a lot of these are available on Better Built Northwest. So I encourage you to check out a bunch of these because it's a great place to get your next round of education. And then, boy, I could just keep throwing stuff at the list, right? Building Science Corporation, Better Building Science, you're not going to find in many places. Building Science Translator, I talked about the Solution Center sales tool. This was the precursor to it, the Building Science Translator. It translates all of our tech speak into a variety of ways to communicate to different types of homeowners. An engineer and an artist probably approach their homes a little differently and need a little bit different ways to relate to the house. So there's just a lot of great stuff here. All of these things are really, really going to be beneficial and helpful to you in moving this stuff forward. So with that, I'm going to throw up my contact information and we'll kind of open it up for the last 3 minutes for any final questions, chat, accusations, curse words, whatever.
Another question coming in, which I think is a great one when we think about the wildfires this year, especially out west. But various brands of ventilation equipment have been integrating high quality particulate filters to filter incoming outdoor air. So far, they've not found any that integrate robust chemical filtration like lawn equipment fumes, vehicle exhausts, toxic scented dryer sheets, pesticides, urban air pollutants. Do you know of anyone planning to integrate chemical filtration into ventilation equipment? Or maybe you want to talk about both of those, Dan, that you can add outdoor air filtration. What are the different levels that you want to add?
Yeah, it's terrific and terrific question because there's no one right answer to this because what you just did is you identified a problem that's only getting more and more real every year. And there, for many reasons. One, we're identifying more easily and readily people who have chemical sensitivities. We're better at being able to understand and identify that. And we are having an explosion of wildfires and we're finding that we need to build closer to the freeway. And, all of these types of challenges are all very real. So a couple of different things I'm going to mention. There are a couple of different approaches to trying to solve or reduce the impact of these problems. One is what they refer to as smart ventilation controls. And these would effectively have an outdoor sensor that would look for kind of when an outdoor pollutant hits a peak moment. And during that time, it would temporarily turn your system into a recirculation system and then over-ventilate for a short period of time once the outdoor numbers have dropped below. Obviously, there can be challenges with this because every homeowner is different and building a sensor that senses everything sounds really expensive. And how long do sensors stay sensitive? All of those are real problems. But you can see that conceptually, how that could be a benefit. Another part is just doing really good particle filtration and maybe adding things like charcoal embedded into the fibers. Now, that stuff can work. Typically, the problem is not that long of amount of time in terms of the charcoal, activated charcoal and what it can do. But going with the MERV 13 filter that is deeply pleated, so it has a lot of surface area, maybe charcoal embedded is probably your best overall filtration approach where you're looking at combination of cost and complexity versus benefit. Yes, you can find filters that are MERV 16 and HEPA filters, but you start putting HEPA filters on this equipment and you literally need to build bypasses around them to reduce pressure. And what's the point of that? So going with now the other thing is there are magic boxes that are coming. Some of them use, crazy lights or electrostatic flashes and ozone and all these things that make wild ionization, that make a bunch of promises that so far most of our indoor air quality science tells us we cannot truly connect the benefit to using these products And in fact, many of them actually have negative components. If they generate ozone either intentionally or as a byproduct, it's a negative. And some of them, it's more just the negative is you're spending thousands of dollars on something with a negligible impact. So unfortunately, I wish I had I had said, boom, go to this website. They've got it all answered. They don't, but there are a lot of people who are thinking about this.
Yeah.
And usually that means that innovation is bound to happen at some point in time.
Yeah. I think we've talked to several manufacturers that are thinking about that.
Yep.
Are, you know, they got the engineers working on systems today. They see the need. So it's great advice, Dan.
Yeah.
Dan, another question.
Sure.
This attendee has a tight house, round 2, exhaust only ventilation. Does it make sense to put a MERV 13 filter on a passive air vent, or will the exhaust not be powerful enough? Or perhaps what is your recommendation for somebody in that predicament?
Yeah, it's an interesting predicament to be in. So a lot of it, you know, of course, unfortunately, the answer is it depends, right? It depends on where the leaks are currently in your house. Airflow is like a teenager. It goes where it's easiest to go most of the time.
Right.
So you know, a different way to say it is airflow. It's kind of like proving murder. You need both a motive and an opportunity.
Right.
The opportunity is the hole, the motive is the pressure. So if you were able to get the house, if you were completely sure you've sealed off the attic, the garage, and the crawl space, the 3 naughty places from my image earlier, and you wanted to do something like a passive hole in the wall with the filter in it, yes, you're going to get a large percentage of the air coming through that. Is it really going to do that job? Probably not. Linda Wigington did a study and found that in some houses of the right types of tightness and the right age and the right amount of insulation, the building itself, if you sealed all the big holes, the small gaps and cracks actually ended up working like a MERV 8 filter or something of that nature in the house already. So at some point in time, is adding an extra hole helping or hurting? My actual recommendation would be to match the exhaust ventilation with an inline supply fan, a high quality Panasonic or Delta Breeze or somebody Brown that it is rated for 10,000 hours of continuous use, because that you can build a box on it and you can put an inline heater on it. Some of them come with inline heaters optional. You can put a filter box on it, put a UV light on it. You can hook up a dehumidifier, whatever you want to do. That is probably your single best bet. And operate at a neutral pressure or close to that when your ventilation system is running. There's a whole nother discussion about what's called the half fan rule. Turns out really leaky houses and really tight houses don't move as much air as you think they are going to out of their fans. They actually move about half as much. It's a whole different discussion for a different day. I only half understand the physics of the half fan rule, which just means I know about a quarter of what I need to know probably. But my point being, the truth of the matter is exhaust only in really tight and really leaky houses, you're not actually getting what you think you're getting out of your fans. Balanced ventilation eliminates that problem. So that's my best recommendation there.
Great advice. Well, I just want to thank you for your time today. It's always great to get a chance to talk to you. And just want to let everybody know, Dan will be back on Thursday, June 10th at 2 p.m. Central Standard. And we're going to talk about options for advanced walls. So looking forward to that topic.
Yeah. If you've ever wanted to know what a Martha wall is, show up on June 10th and we'll talk about the Martha wall.
Fantastic. All right. Thanks, everyone. Have a great day.
Thanks, everyone.
Thanks, Dan.